Hello everyone, welcome to M for Mathematics. In this video, we'll be doing Feb March 2024 paper 3-2. Its first question is, find the quotient and remainder when x to the power 4 minus 3x cube plus 9x square minus 12x plus 27 is divided by x square plus 5. So in this case, we should do long division method. We will divide the given polynomial x4 minus 3x cube plus 9x square minus 12x plus 27 by x square plus 5. So first of all, we need x square. So it becomes x square into x square will be x to the power 4 plus 5x square. So we should write like terms together. So I'm putting 5x square with 9x square. And then we'll subtract. So this will become minus, this will become minus, this will get cancelled. Now we are left with minus 3x cube plus 4x square. Rest will come as it is, minus 12x plus 27. Now we have minus 3x cube and here we have x square, so we should multiply by minus 3x. So it comes as minus 3x cube. Then minus 3x and 5 will be minus 15x. So we'll write like terms together. Again we'll subtract, sign will change. So this minus 3x cube plus 3x cube will get cancelled. 4x square as it is. 15 minus 12 will be 3x plus 27 as it is. Now we have 4x square and here we have x square, so we should multiply by 4 so that here we'll get the same term, and that is 4x square. Then 4 will multiply with 5, so this will give you 20. Again we'll subtract, sign will change. 4x square will get cancelled. We are left with 3x plus 27 minus 20 will be 7. So remainder is 3x plus 7 and quotient is x square plus minus 3x plus 4. This will be the quotient. So this will be the answer for the first question. Quotient is x square minus 3x plus 4 and remainder is 3x plus 7. Now move to the next part. It says find the coefficient of x square in the expansion of 2x minus 5 under root 4 minus x. This question carries 4 marks. Okay, so let's start. 2x minus 5 will remain as it is. This 4 minus x root, it means whole raised to power half. So first of all, we should take this 4 common. So it becomes 2x minus 5, and when we pull 4 out, its power will become half. Inside the bracket, it will be 1 minus x over 4 whole raised to half. 4 raised to half will become 2, so I'm putting this 2 in front of this 2x minus 5. Now this is 1 plus x to the power n, formula will apply here. So it is 1 plus nx, n is half, x is minus x over 4, plus n minus 1, upon factorial 2, into x square. So in place of x we have minus x over 4. We'll square it. So as they have asked only the coefficient of x square, so no need to expand anymore. So we'll leave it like this. So now this will become, we can write it as 4x minus 10, and here we will have 1 minus x over 8, and this is half. This will become half minus 1, that is minus half. So minus 1 over 4 and 2 from the denominator, so it will become negative 1 over 8 into minus x upon 4 whole square will become x square upon 16. So now we need only coefficient of x square. So what we'll do now, we'll find terms with x square, okay? Terms with x square. So first term will be when 4x will multiply with minus x over 8. This will give you x square. So I'm putting the complete term with x square. So it will be minus 4x square over 8. And then this minus 10 will multiply with next term, that is minus 1 over 8 into x square upon 16. We'll get x square again. So this negative 10 and negative 1 by 8 will become plus 10x square over 8 into 16. So we are looking for the coefficient of x square only. So it will be minus 4 over 8 plus 10 over 128. Now take the LCM and simplify. LCM will be 128. It will become minus 64 plus 10. So that gives you minus 54 over 128. Or if you simplify it, it comes as minus 27 over 64. So this will be the coefficient of x square in the given expression. Let's move to the next part. It says state the set of values of x for which the expansion in part A is valid. So if, let me show you that from where we'll get the answer. So look at this step. Here we have 1 minus, because we expanded only this part, rest of the things will remain same. So we need to just check this one. So it says 1 minus x over 4, and condition is that such expansions are valid if x is, numerical value of x is less than 1. So our expansion is 1 minus, it's 1 marker question, so not much details are required. So this was the case. So my x is x by 4. So we need to put condition on this only, that numerical part of, numerical value of this x should be less than 1. So from here we will get that mod x should be less than 4. This will be the condition. Only in that case expansion will be valid. This is for 1 mark. Let's move to the next question now. Question number 3. This is from complex numbers. It is given that z is equals to minus root 3 plus I. Express z square in the form r e raised to I theta, where r is positive and theta is in between minus pi and pi. Let's start. Express z square. So first we should find z square. This question carries 3 marks. It means we should square minus root 3 plus I. Apply a plus b whole square, so it will be 3 plus I square minus 2ab. I square is minus 1, so 3 minus 1 become 2, so it is 2 minus 2 root 3I. This is our z square. So z square is this complex number now. So first we should find r. R is the modulus of any complex number, so this will be under root this 2 square plus negative 2 root 3 whole square. This will be the modulus. So it comes as root of 2 square will be 4 plus 2 to the 2 root 3, sorry, this will be 4 into 3 12, 12 plus 4 16, and square root of 16 will be 4. So r is 4. Now we should look for theta, that is argument. Now to find theta, we'll use tan theta is equals to y over x. So y over x means y is minus 2 root 3 over 2. 2 will get cancelled, so this comes as negative root 3. So when we check this argument from the calculator, it comes as negative pi over 3. So it means they've asked to write z square in the form r e to the power I theta. So our z square becomes 4, r is 4, e raised to minus I pi over 3. This will be the value of z square in terms of r e raised to I theta. Now move to the next part. It says the complex number omega is such that z square omega is real and modulus z square over omega is 12. Find the two possible values of omega, giving your answers in the form r e to the I alpha. Okay. Z square omega is real. So theta is minus pi by 3. So we'll use this relation where it says modulus of z square over omega is 12. By the property of this complex numbers, we can say mod of z square upon omega is mod z square upon mod omega. This they have given as 12. What is mod z square? It is 4. From the first part, we can check that mod z square is 4 over modulus of omega is equals to 12. So from here, we can say that modulus of omega is 4 upon 12, that is 1 by 3. So this will be your capital R, this R, because they asked to find two possible values of this omega. So this I am representing as R, capital R, as they have given. So R comes as 1 by 3. So with the information that z square omega is real, it means that y part of the complex number will be 0. Y part is 0. That means imaginary part will be 0. So only the real part is there. So it means when we find tan alpha, because alpha they have given in this case that alpha is the argument, so tan alpha will come as 0 because tan alpha is y over x. So when y part is missing, so that will be 0. So tan alpha is 0. So tan alpha can be 0 in 3 possibilities. If it is, so we can take help from the previous part as well. So we can say that alpha plus theta, because it is product of z square and omega, so their argument will be, so we know this property that argument of two complex numbers, if we have z1 z2, it will be argument of z1 plus argument of z2. So here we have product of 2, z square and omega. We know argument of z square is theta in the previous part and argument of omega is alpha. So I'm making this condition now that alpha plus theta, it may be 0 or pi or negative pi as well, right? So now we have theta already. Theta is negative pi by 3 from the first part. So if I use theta as negative pi by 3 is equals to 0 or pi or negative pi. So we'll have these options. Alpha comes as pi by 3, or we'll shift my negative pi by 3 to the other side. So one option is 0 plus pi by 3. Then next will be pi plus pi by 3. So that becomes 4 pi by 3. Or third result will be minus pi plus pi by 3. So that will be minus 2 pi by 3. So these three options will be there. Out of these three, 4 pi by 3 is not applicable. So we'll drop this value. So it means we have these two results. Alpha may be pi by 3 or negative 2 pi by 3. So now we have r 1 by 3 and alpha has two values, pi by 3 or negative pi by 3. This means we can write omega as r is 1 by 3 e raised to I alpha. So I alpha will be I pi by 3 or r e raised to negative I 2 pi by 3. So these will be the two answers for the omega. Let's move to the next question. It's question number 4. It's based on logarithmic functions. The positive numbers p and q are such that ln p over q is equals to a, and natural log ln q square p is equals to b. It says express ln p to the power 7 into q in terms of a and b. So now first look at this expression. They have given ln p over q is equals to a. So here we can apply property of log. So it will become ln p minus ln q is equals to a. So this is equation number 1. Similarly, if we expand this one, apply the property here. So it becomes ln q square plus ln p is equals to b, which again we can write, because this 2 can move in front of ln, so it will become 2 ln q plus ln p is equals to b. So this is equation number 2. Now we can solve these two equations simultaneously. So by elimination method, if we subtract these two equations, ln p will get cancelled. So I'm doing now equation 1 minus 2. So equation 1 is ln p minus ln q is equals to a. Second equation is ln p plus 2 ln q is equals to b, and we'll subtract these two results. So sign will change. This is plus, this will become minus, this will become minus, and this will also become minus. So ln p will get cancelled. Minus ln q minus 2 ln q will become minus 3 ln q is equals to a minus b. So this will be the value of ln q. Now put this value of ln q in any of the equation to find ln p. So we can say that ln q, I'm shifting minus 3 to the other side, so it will become 1 over 3, and we'll adjust negative sign as well, so it will become b minus a. This is ln q. Now put this value of ln q in 1 and we'll solve for ln p. So ln p becomes a plus ln q. This is from equation first. Now what is ln q? Ln q is 1 over 3 b minus a. So substitute that value here. A plus 1 over 3 b minus a. Take calcium, 3 will go up, it will become 3a. 3a plus b minus a will become 2a plus b over 3. So this is ln b. Now look at the question. What they're saying? They're saying express ln p to the power 7 into q in terms of a and b. Ln p to the power 7 into q. Okay, so it is ln p to the power 7 into q. So this will become ln p to the power 7 plus ln q. P to the power 7 will become ln 7 ln p plus ln q. So now put their values. Ln p is 2a plus b over 3. Ln q is 1 over 3b minus a. LCM is 3, so it will become 14a plus 7b plus b minus a over 3. 14 minus 1, a will become 13a plus 8b over 3. This will be the value of ln p7 into q. Rest of the questions we'll do in the next video. Thank you for watching my video. Keep watching my channel M for Mathematics.